Okay, so today we're going to break down a command line to-do list. I know, it seems almost too simple to even talk about, right? But its design, well, it holds the key to a really powerful software concept. We're going to see how even the most basic program can teach us how to build things the right way.
So what is this thing? On the surface, it's a super straightforward in-memory task manager. You open it up, you add your tasks, you get organized. But you got to pay attention to that in-memory detail. It's there for a reason, and it reveals the whole point of this design.
Exactly. You're probably thinking, if it's just a basic to-do list, why are we even talking about it? And the answer is awesome, because it's not about what it does. It's all about how it's built. Its architecture is a perfect, bite-sized example of a professional software design philosophy.
All right, so first things first, let's take a quick tour of what this thing actually does, from your perspective as a user.
So yeah, it's got all the stuff you'd expect. You can add, you can view, update, and delete tasks. What we developers call CRUD operations, right? Create, read, update, and delete. You can also mark things as complete, get help if you're stuck, and of course exit. Super simple, super effective.
And check this out. The user interface is actually pretty flexible. You can use numbers, like 1 for add, or you can just type out the word add. Now, this might seem like a tiny little detail, but trust me, it's our very first clue that there's a really thoughtful separation happening between what the user types and what the app actually does on the inside.
Okay, so that's the what. Now let's pop the hood and see the how. And this is where we get to the blueprint, clean architecture.
So what in the world is clean architecture? Well, at its simplest, it's just a way of organizing your code so that the different parts of your application don't turn into a big tangled mess. Think of it like building with Legos. Every single piece has a very specific job, and they connect in these really clear, intentional ways. So your data is totally separate from your business rules, and those rules are totally separate from what you, the user, actually see on the screen.
And this idea of separation isn't just some high-level concept. You can literally see it in the file structure. There's a file that only cares about defining what a task is. That's its whole job. Then there's another that only handles the logic of adding or deleting stuff. And finally, a third one that only deals with the user interface. See, each piece has one single clear responsibility.
Now, I know this can still feel a little abstract, so let's use this really great analogy from the source material that's going to make this whole thing just click.
Here it is. This is the key. For just a minute, forget about code. Just picture an office whiteboard. A temporary space where a team can get organized. This simple idea, it unlocks the entire design.
All right, let's build out our little office team. First up, we've got model/task.py. Think of this as the sticky note template. Its only job is to say what a task looks like. Every single note has to have a title and a status. Simple. Next, taskservice.py. This is our board manager. This is the person who's physically adding, removing, and keeping track of all the notes on the board. Then there's interface.py. This is our receptionist. They take requests from you, from the outside world, and pass them along to the board manager. And finally, validation.py. This person is the rule keeper, checking requests for silly mistakes like, hey, you can't add a blank sticky note. See how every component has a very distinct human-like job?
Okay, so we've set up our neat little office team. It's organized, it's clean, but really, why go through all this trouble for a simple to-do app? What's the big payoff here? Oh, the benefits are huge. First, organization. It's so clear. Everyone knows exactly what their job is. This directly leads to maintainability. If you need to fix something with the receptionist, you can do it without worrying about breaking the board manager. And maybe most importantly, testability. You can pull the board manager aside and test if their logic works perfectly, all on its own without even needing the receptionist to be there. This separation is what makes software robust, flexible, and honestly just sane to work with.
But let's circle back to our analogy for a second. What happens at the end of the day in an office with a temporary whiteboard? Well, someone comes along and wipes it clean. And that's exactly what in-memory means here. The second you close the application, poof, all your tasks, all those carefully placed sticky notes are just gone.
And this leaves us with a final, really important question. Our app is beautifully designed, right? But its memory is temporary. So how do you fix that? Well, because of its clean architecture, we can easily swap out that temporary whiteboard for, say, a permanent filing cabinet, like a database or even a simple file, and we can do it without having to retrain the whole team. So the real question isn't if we can give it a permanent memory, but what kind of memory it truly deserves. And that's a whole other adventure.